Okay, number 4, find all angles in degrees. So sine is root 2 over 2. So sine is a positive in the first and second quadrants. And that's root 2 over 2 is always a 45-degree angle. So we're talking about all angles in degrees. So one answer is going to be 45 degrees plus or minus 360 degrees N. And then the other angle is going to be 135 degrees plus or minus 360 degrees N. So why do we add on this plus or minus? Well, because it's all angles and it's in degrees. So that's why I'm using degrees. So all angles would mean, all right, so we're going to get this one, then we're going to go around again 360 and get the next one. We're going to go again 360 and get the next one. You're going to keep going. Same with the 135. Find whose angles whose tangent is root 3. So we know that the tangent of 60 degrees is equal to root 3. Okay, and you should also know that the tangent of 30 degrees is equal to root 3 over 3. So if tangent is positive in the first quadrant and the third quadrant, because tangent is y divided by x, and y and x are both negative. So this angle we already established is 60 degrees, but this other angle is going to be 240 degrees. But we want all the angles in degrees, so we're going to add plus or minus 360 degrees N. And then find all angles whose cosine is negative. So where's cosine negative? Cosine is the x, and x is negative in the second and third quadrants. So that's negative a half. Okay, so that is creating a 120 degree angle and a 240 degree angle. But we want all the angles, so we're adding plus or minus 360 degrees N, plus minus 360 degrees N. And then find all the angles in radians. So now, all these problems are the same. So you need to convert all of your degrees to radians. So converting 45 degrees is pi over 4 plus or minus 2 pi n. And then it will be 135 is 3 pi over 4 plus or minus 2 pi n. 60 degrees is pi over 3 plus or minus 2 pi n. And then 240 degrees is 4 pi over 3 plus or minus 2 pi n. And then cosine is negative 1/2, 120 and 240. That is going to be 120 degrees is 2 pi over 3 plus or minus 2 pi n. And then 240 is 4 pi over 3 plus or minus 2 pi n. Okay, part 6. Find the exact value. So you're not just punching in sine of 75 in your calculator. So you have to use the sum or difference identity. So I could write 75 as the sine of 45 plus 30. So I want to take two angles that can actually find the exact value of. So I didn't want to do 40 plus 35 because we don't have the exact value of sine and 40 and sine of 35. But I have the 45 and 30, so I'm going to use the formula that this is going to be A and this is B. So using the formula, it's going to be sine of A, which is 45, times the cosine of B, which is 30, plus the cosine of A, which is 45, times the sine of B, which is sine of 30. And then what you need to do is you're going to use the exact value of each one. So sine of 45 is root 2 over 2. Cosine of 30 is root 3 over 2. Plus cosine of 45 is root 2 over 2. Times sine of 30 is 1/2. So simplifying that, you're going to have root 6 over 4 plus root 2 over 4. And you can leave it like that, or you can leave it as root 6 plus root 2 over 4. Okay, cosine of 15, this is going to be a subtraction one, so I could write this as the cosine of 45 minus 30. Or I could do 60 minus 45. Same thing with the other one. I could have done, let's see, or that's all I can think of I could have done for that one. So this one, the subtraction with the cosine, it's going to be cosine of, the formula is cosine A, cosine B. So cosine 45, cosine 30, plus sine 45, sine 30, times the sine of 30. So again, I'm going to find the exact value of each of these. So it's going to be root 2 over 2 times root 3 over 2 plus root 2 over 2 times a half. And it's going to end up being the same thing as this one. Okay, part 7 is looking at, okay, I'm noticing that this one goes cosine, cosine, minus sine, sine. So what formula is that? Well, that is going to be the cosine of 50 plus 40. Because it's the cosine of A plus B. Because the cosine of A plus B has a subtraction in between. So this is actually the cosine of 90, and then you need to go further and actually find the cosine of 90, which is going to be 0. So this expression is equal to 0. This expression goes sine cosine plus cosine sine. So that's going to be the sine of A plus B. So this is going to be the sine of 270, which on your unit circle is going to be -1. Okay, for these problems right here, you want to use, you could use your identity sheet. So for 1 and 2, I'm just noticing that this is the same thing as cosine of A minus B. So I'm going to use what I did in parts 6 and 7. So this is going to be cosine x times cosine pi, and then plus, because this is a minus, I'm using the subtraction property, which is opposite, sine x sine pi. And I'm going to simplify each one. So the cosine of pi is over here. It's the x value is -1. So this is -1, which turns cosine of x times -1 into negative cosine x. Now let's look at the second part, sine of x, sine of pi. So what is sine of pi? What's the y value here at pi? Well, it's 0. So this whole part wipes out. So the answer is negative cosine x. Now I'm going to do a similar thing with sine of x minus pi. So that's going to use the difference formula for sine. So it's going to be sine of x cosine of pi minus cosine x sine pi. So let's simplify this here. We have cosine of pi, so that's the x value, that's -1, and then we know that sine of pi is 0, so this part wipes out again. So again, it's going to be negative sine x. Okay, number 4, I kind of went out of number. But number 4, 5, and 6, I'm just going to use my trig identity sheet. So number 4 is a cofunction identity. The cosine of theta minus 2 over theta is actually equal to the sine of theta. That's these two are cofunctions. And then 5 and 6, I'm using a negative angle identity. So cosine of negative theta is the same thing as the cosine of theta. And then using sine of negative theta as a negative identity, it's going to be negative sine of theta. So in a right triangle, if the cosine of 30 equals x, then the sine of 60 equals x. Because this is using a co-function identity. If these two have the same ratios, then their angles need to be complementary. And I can do that with a diagram too. Let's do it with a diagram and show. Okay, so if this is my 30 degrees angle, this is, and I don't know what this is. Okay, it's in a right triangle. But I know that the ratio for cosine is x. So we can just put in, let's put in the adjacent is x and the hypotenuse is 1. So the sine of what angle is x? Well, the only other way to get x with a sine, remember sine is opposite over hypotenuse, is to go x divided by 1, and it's got to be from this angle. Well, this angle in a right triangle must be a 60-degree angle. So that's how I get 60. So I can do another example. If we know the cosine of 72 equals 3/5, then the sine of what is equal to 3/5? Well, these two need to be complementary because they're co-functions, part of our co-function identities. So this must be 18 degrees.